This conference
such a
will
way that,
now be recorded.
okay, so it get adjust such a way that, okay, training is performed using a labeled data set of input in a wide representation of the input pattern, and that targeted with intended output response. Training uses a general purpose method to iterative determine to weight the immediate response or also the final neurons which is available in the network. So this will be happening. Okay, here again, can you guess, can you compare these two diagrams and can you guess what it is? Can you type something if possible? Here I mentioned two diagrams. What may the difference or similarities? Any guess from your side? Okay, neuron of our body, biological neuron. Yeah, at the left side it's a biological neuron. The same thing at the right side in a mathematical form. Both are same. Okay, so here it's a biological form and this is a artificial neuron network. Yeah. Okay, so I just checked. Okay, so now I'll be connecting with the CNN block. Okay, in a CNN block, the convolution plays a future role. Okay, so the role of the future extracted, but they are not hand designed. Okay, convolution filter and the kernel weights are decided during the training process. It's based on the research work and it's based on the filtration what you are going to use. So if I'm saying about the kernel is nothing but a filter. Okay, even if I'm saying about the kernel term called kernel or filter, both are approximately same. Okay, so that's what I'm trying to say. Okay, so both are same. Okay, it will be useful in a training process. Okay, convolution layers are able to extract the local feature based on restrict the receptive fields of a hidden layer to be the local. Okay, so these things are all processed by the convolution. Here I'm having an image. Okay, this is around 32 cross 32. So I'm reducing this image into 28 cross 28 of about 108 images. Okay, so here the convolution process has happened and subsampling is also happened. This after the convolution, I'm converting a sample into a multiple sample. Okay, let's assume I'm having an image. Okay, I'm taking I'm having an image of around 20 centimeter cross 20 centimeter. Okay, I'm going to cut the image vertically, column wise. Okay, let's say I'm having an image of dog. Going to cut the image in vertically of giving a space of around 1 centimeter. So I can have 20 pieces of images. Okay, so now again I'm taking the first images and second images. So continuously I'm taking a images together and odd images together. Okay, again I'm cutting the entire image in a horizontal manner for around 20 pieces. Okay, now if I'm having a dog, you might have seen in some YouTube video also, if I'm having a dog or cat or ball or your image, okay, this practically says your image pixel size is reduced, but you can able to see 4 different images. Okay, this is a process of subsampling. This is the process of subsampling. Okay, so based on this, how much samples that you are going to create it. Okay, so practically for a particular image, okay, 75% of the 25% of the data is enough to identify rest of the 75% of the image. Okay, for the classification process. So that's what CNN block is processing. Okay, This will be used in a variety of areas, including image and pattern recognition, speech recognition, NLP, and also the video analysis. There are a number of reasons that convolution network becoming important in this traditional model for pattern recognition, feature extraction, or hard design. In CNN, the weight of convolution layer being used for feature extraction as well as the fully connected layer being used for classification are determined during the training process. The improved network structure of CNN led to saving in memory requirements and also the computation complexity requirement. At the same time, it will give a better performance for the application where the input has the local correlation. Okay, so then I'll be connecting with the pre-processing ROI selection, precise modeling of ROI. Okay, so in this case, okay, 1 minute. Yeah, and also finally the decision making. Okay, in this case, okay, it consists of 4 stages. Okay, so it pre-process the image. Okay, ROI means regions of interest. What are the region? If you are focusing on cow image or parrot image, you will be concentrating on the pattern of the beak. Okay, so the pattern of beak is different from the pattern of pattern of beak of is different from pattern of beak of a parrot. Okay, so this is nothing but a where in which pixel this pattern gets false. So this is nothing but a region of interest that contain likely objects like vision decision making. The pre-processing step is usually depend on details of the input. It's purely based on the input, especially the camera system, and it's often implemented in a hardwired unit outside the vision subsystem. Okay, decision making at the end of the pipeline typically operates on recognized objects. End of the pipeline typically operates on recognized objects. It may have complex decision, but it operates on less data. So these decisions are not usually computational hard or memory intensive problems. The big challenge is in the object detection and recognition stages where CNN are now having a wide impact. Okay, so this is how the CNN or image processing. Previously it was an image processing. Now it was in data analytics. If it is an image processing, if you are taking an image, you will be having let's assume around 20 cross 20 pixels. Totally 2 cross 2 400 blocks are there. Okay, so in which if I'm taking a person images of 20 to 20 cross 20, if a particular person eye is false under the 4 cross 4 space, if the same thing happened, then only it can able to recognize. So this is nothing but a image processing. Okay, whereas after the DL, okay, even this is shifted to some other pixel, it has to recognize. So that's the process of what I'm explaining here. So then only it can able to take the decision, which can be a motion analysis or match or flag events. It can be anything. Okay. So this also a process of how the different values of the input is fed. Okay, so here I'm having an input feature map. Okay, here I'm having some output kernel space. I'll be connecting with filter. Okay, so by basic after the convolution is processed. Okay, let's assume I'm having an input of n cross n matrix. I'm having a filter of m cross m. Okay, output layer will be n minus m plus 1 cross n minus m plus 1. Okay, so that much of blocks will be there. So that much of pixel will be there. So it will be connecting to the matrix. So we need to identify the input. Okay, how we are going to identify the input? So that's the challenge. Okay, here I just shown some diagram. Okay, here I fed the input, I gave the convolution output, how this gets processed. So everything, I mean, here it mentioned it's a n k. Okay, so practically h should be n minus d plus 1. Okay, that much of matrix will be there. Okay, even I'll be explaining with pure mathematical calculation also. Okay, so let's assume I'm having an image pattern. Yeah, don't say. I'll be sharing one more screen to you. So I just took the basics of what is CNN. Okay. So now I'll be calculating on, I'll be connecting on what is that image processing. Okay. So if I'm having an input, let's assume I'm having an image. Don't consider it as a matrix. This is an image of 3 cross 3. Okay. So it's based on the color. It has some values. So these things you guys knows very well. Okay. So here I'm having a kernel, the filtration methodologies. Okay. If I'm adding this layer over the input, it gives output for this midpoint. Okay, connecting to the dot product, -3 plus -2 plus -1. So here these things are all 0. 1 plus 6 plus 1, the final answer. So that's what I'm going to show you. So here you need to do the dot products. Okay, the final answer will be 2. So I'm adding 2 here. Okay, this how that convolution process is happening. Okay, this how the convolution process is happening. Okay, again, if you are designing, you need to choose the kernel. Okay, if you are having clear idea of kernel, then you can able to connect based on your pattern, and it's a mathematical calculation from your side. Okay, so here I'm having some input, here I'm having kernel, here output. So then the next moment, if can we place this kernel over here? Here means like this. Yes, that's also possible. That's also possible. But if I'm placing this kernel to a particular input, okay, that midpoint data will be connected to the output. Okay, this this process works. This process works. Okay. So here I'm having a multiple level of a kernel. One is a vertical line detector, another is a horizontal line detector. Okay, and a corner detector. Again, I said right. There is a n number of already existing filter is there. Okay, but you need to choose which filter you are going to use for your research project. Okay, so again, it's based on the individuals. Okay, but there is some, I mean, if you're googling it, you'll be getting what are the different filters are available. Okay, these things you can able to check it. Here I mentioned it as a 111. Okay, in some cases, okay, for vertical line detector, the -1 are all zeros and 1 are all 1. Okay, and in some other cases, these things will be -1, these things will be 0, these things will be 1. So it's based on the project and research. Okay, but if it is a vertical line detector, okay, so the vertical line will be having a common data. Okay, so once, I mean, if I'm connecting to the edge, okay, so here you can able to see 1 2 3 4 5. Okay, 5, this is the filter. 5 minus 3 is nothing but 2, plus 1 is nothing but a 1. That's what I said, n minus m plus 1. Okay, so the red color are all real data. Okay, this is the filtration process. Okay, once this filtration process is happened, here I can show you. Okay, this matrix gets detected. this matrix, middle matrix. So ignore the first row, first column, and last row, last column. Okay, this pattern of matrix. So this gets compressed. Okay, that will be a processed here. Okay, so for this convolution, this is the data. For this convolution process, this is the data. Again, based on the movement of filtration, you need to do the filtration for each and every space. Again, you need to shift this filtration to here. Okay, this will come here, this will come here, and this will come here. Okay, you need to do the filtration process. Okay, then for that, this data will be connected. Again, for this side, 1, 2, 3, this side, this data gets recognized. So finally, you can able to get the entire matrix after the entire convolution process. This convolution process gets changed. Okay, then only we can able to identify. Okay, you need to do the two things you need to identify. One is proper filter. Okay, another one is you should know the dot matrix. Okay, so dot product. Okay, so you need to calculate it and recorrect it. So this is the convolution process is happening. Okay, so now once this is processed, again if I'm connecting this and separating these things based on this only, our pattern will work. Okay, let's assume here if I'm having a 23 as a data. Okay, if there is a 23, there might be some B. Again, if I'm doing some more filtration process, then I can able to connect. Oh, this is B, this is mouth, this is I. Based on this value, okay, you can able to connect it. So this is nothing but a convolution process, and you can have an input of a multiple way and the padding. Okay, so here you might have seen that by general, okay, these things are without padding. Okay, if I'm connecting with padding, okay, if I'm connecting with padding, this will be a different case. Okay, here I converted 5 cross 5 matrix into 3 cross 3 matrix by having a filter around 3 cross 3 matrix. Okay, you can ask me, this first row, first column, last row, last column is almost ignored. This will be used for this one. Whether we can have this data also, we can have one more row or one more column for our convolution of, yeah, yes, we can have. So this will be processed via the padding only. Okay, so that's what I'm going to explain, the padding. Okay. Okay, so by basic, if I'm doing this, I can able to get the data of here. So this calculation you know very well. Okay, I don't want to explain again. Okay, so for padding, I am introducing one more row, one more column in the input side, making all this data to be zero, all this data to be the zero, and I'm connecting the filter over here. I can able to get the value over here. Okay, here practically 1, 2, 3, 4, 5, 6, 7 minus 3. Okay, it's nothing but 4 plus 1, it's 5. Now you can able to calculate. This is nothing but a 5 cross 5 matrix. Okay, this is 7 cross 7 matrix. Again, once you did with the padding, you need to calculate the rows and columns based on the padding data. You can't calculate just like that. So these things are all important. Again, even if you are focusing on the images, edges also, you need to concentrate on padding. Okay. So the kernel here, it's again, it's up to you to decide. Okay. Based on your arguments. Here, if you are not having a padding, okay, slide example. Practically you'll be having a 3 cross 3 matrix output. Okay, even if I'm not connecting other edges, I'm connecting only the corners. Okay, I'll be converting the output as like this. I'll be converting output as like this. This is example without, I mean, by connecting only the corners. Okay, again there may be I mean, if you are concentrating more on corners, you can able to concentrate these examples also. I mean, this type of methodology also, it's again in number of ways that you can able to connect it. Okay. So width padding means again the edges you are going to concentrate, and width padding means this is a different method. Okay, these things are all can be connected for the CNN algorithm. Okay, so the next thing is pooling. Okay, so this is the interesting mechanism. Okay, so if I'm having a image, I mean, I just go to the matrix directly. If I'm having an image of 4x4 matrix, okay, so I need to connect the output as, I mean, I'm not having any filtration process. Okay, the filtration process is previous methodologies. Okay, here I need to convert into a 2x2 matrix. Okay, so for this case, max pool. Max pool means in this matrix, what's the maximum value? 8. Okay, I'll be writing 8 here. In this matrix, 5. Here it's 1. Here it's 4. I'm writing 8, 5, 1, 4. Okay, so this is for max pool. Okay, if you are concentrating instead of max pool, if you are concentrating on average pool, then this will add everything and divided by 4. That will be placed here. So even I'll be showing. So these things are all average pool. Okay. So again, so there is a concept called pooling, and again, even if you are calculating, you can able to connect with what you are going to do. I mean, it's based on the research. They will be having some constant also, connecting to the constant and dividing for the constant. So these things you can able to connect it. Okay. So this is what the mechanism under the CNN mechanism or the conceptual. Okay. So if you are doing a CNN, you need to know these things. Okay, these things are all fundamentals. These things are all fundamentals. So now, actually, this is what I tried to explain at the beginning also. So here you are having images, and after convolution, it connects to the multiple matrix. Again, subsampling. Okay, it separates and it practically it cuts the process and it separates and connecting the same image into around 4 or 5 different layers of the image. So again, this can be connected to the subsampling. So until, I mean, even if you want to connect for 20 times or 30 times, it's up to you. Okay, even if you have worked with the Photoshop, okay, you might be working with the Gaussian filter. Okay, this will be connect with this will combine 3 or 4 pixels together and take the average value and connects the corresponding color. So this may get dull. Okay, again, it's based on the filtration level that you are using the Gaussian filter or blur or whatever it may be. Okay, you can able to do it. Again, this is purely based on the kernel. So here, let's assume simplest diagram. I'll take one more link now. Let it be. I'm taking a randomly. Let it be the same diagram. I'm taking this edge only. I'm taking this edge only. For the next feature, this edge might be somewhere like here, somewhere like here. Again, this edge. This is nothing but an input for this neurons. Here you will be having neurons. Okay. So for this, you need to calculate more on what is deep learning is. Okay. If you are directly going to CNN, it's hard to connect. Okay, you should know what is DL it is. then only you can able to connect with the multiple neurons and connecting to the sampling network. Okay, so I think you got some idea of what is CNN. Okay, now I'll be showing some program. Okay, and I'll be showcasing you. I'll be sharing those screens to you. So here I'm showing multiple lines of program. Okay, here it will identify what it is. Okay, so that's the process that I'm explaining you now. Okay, here you can able to see the input image. Okay, so this input image it's written as a 7 over here. This identifies the filter process. Okay, the input image with filter. Okay, so here the maximum thing is it starts at the initial point. It identifies the 3 edges, these 3 edges. Okay, so by connecting these 3 edges, it identifies the edge pattern. Then based on this will be connecting to the convolution process. Then it says this is nothing but a 7. Then it says this is nothing but a 7. Okay, so for these things, how this will be connecting to the TensorFlow, how these variables gets initiated, how the helper function optimize the iterations. So that's what I am showing here. Okay, here how many iteration you are declaring. Okay, so initially you are considering, sir, your example is not seen. Oh, sorry, I forgot to share the screen. Okay, I'll share the screen. So I think, is this visible?
Yes, sir.
Yeah, so this is, I mean, I'm just taking from the basic example from colab.research.google.com. Okay, so if you want to try any ML or DL or AI mechanism, you can use the Colab. Okay, because if you am installing Anacondas, still there might be some problem. So but all the packages are mostly installed in Colab, so I'm using Colab. Okay, so there is a n number of examples are there. I'm taking an example and just showcasing you. Okay, and I'll be sharing this link to you. You can also focus. Particularly, you'll be working on colab.ch. So I shared the screen. Okay, so in this I'm taking the image. Okay, so I'm connecting to the convolution layer. Okay, the filter, I mean, again after the convolution I will be getting some images. Again I will be doing this convolution process. Again I will be doing this convolution process. So till I get satisfied. Once this is processed, okay, if I'm adding some data, this gets checked and it will be processed here and connects to the corresponding in which category this will be. This image will be. Okay, here that's what I shown, right? I said, right? Okay, I'm taking a image of 7. Okay, so I'm taking the age of 7, 1, 2, 3, and initial point of the images. So 3 edges and initial point. Okay, this is how the result of convolution. This identifies, oh, here this pattern we identified, this pattern identified, this pattern is identified with some equidistance or with some filtration process. Then the convolution says this is nothing but 7. Okay, the classification process. Okay, so for this we'll be using the scikit-learn for confusion matrix. The confusion matrix for to identify the accuracy. Okay, so math, and here we'll be using a TensorFlow. Okay, so once we start to use the TensorFlow, I'm sure it connects to the maximum data. Okay, so how many what might be the filter size, what might be the first layer. I'm connecting, defining the filter layers, filter size, and the second layer I'm defining the filter size. Okay, what are the data inside the filter? So all these things we are connecting. Okay, here MNIST, you can able to see MNIST. MNIST is a standard uh, data, standard images. Okay, via the images we'll be connecting with a different format. Practically, this is nothing but a modified National Institute of Standards and Technology database. This is a large database of handwritten digits, which is commonly used for training a various image system. Okay, so we'll be using via the MNIST. Okay, so in this MNIST we'll be connecting with already existing data. Okay, so I'm just how many data it got trained. Okay, the validation, the test data, so all these things I'm just connecting it. Okay, I'm just taking I mean how I'm going to load data, so that's what I'm mentioning here. And this functions, okay, these programs are all, I mean, is it same as Kaggle? Yeah, this is same as Kaggle. Okay, so here MNIST is we can use in Keras also. Okay, whereas n number of images are available. So these things are all basic examples for you to define what is CNN. That's what I'm just opening this, nothing else. You can use Kaggle. Okay, it's up to you. Okay, so here I'm just plotting it. Okay, based on the I'm creating. So one after the I'm connecting with the different here. These things are all datas. Okay, these things are all programs. So if I'm connecting an example, I'll be having all these programs in a different way. So even I can write a program and I can show the program also. That program also I can able to show. But whereas if I'm connecting with the real example which is given by the Google, I'm sure that even if I'm not available, you can able to do these program steps. That's what I'm sharing this screen. Okay, so this is the first level of convolution process. So what will be the shape here? ReLU. So if this case is happened, okay, ReLU is mostly if you are having a filtration as a negative number. Okay, the negative is changed to the 0 and positive will be the same. So the filtration gets changed. So again, there also you can able to connect, and it's up to you to choose how that image or how you can able to predict these answers. So these things are all performed using this methodologies. Okay, so again I'll show to the, I'll go to the, so this is the input image. Sorry. Based on this, how this identifies. So here practically you can able to say this is nothing but 4. Okay, how this convolution process is processed. So that's what I'm just explaining to you now. I just explained to you now. Okay, I think if you know the pooling, padding, all these mathematical operations, this will be helpful for you to convert it into the normal image into a smallest image where you can able to identify or classify which type of the image it is. Okay, if you are focusing on human faces, you need to have a large number of data set, then only it will be applicable. Okay, so I think I gave some ideas about what is CNN. Okay, to do this, you should know ML first, then DL first, then you should know what is DL, and you have to connect with the multiple data. Then only you can able to connect with the CNN or R, whatever the algorithm you want. Okay. Everything is a mathematics. Nothing is there. Okay. The thing is, you need to identify it. Even if you want to know these, I mean, someone asks, can I get the link or can I get the PPTs? Yeah, everything is available. I will be showing that space. I'll be explaining everything under the Intel platform only. Okay. So here, if you type Intel space deep learning, okay, so you can able to get this link. So I'll be sharing this link also. Yeah, someone please share the PPT to your mail ID. So all the PPT is available in this Intel website itself. You can use for your knowledge purpose. Okay, here they mentioned, I mean, week 1, week 2, week 3 approaches. In week 6, you can able to see what is CNN it is. Okay, so this is not only, I mean, this is purely for free of cost. Okay, not only due to Corona. Okay, Intel is providing all this technology under the Intel platform for free of cost to everyone. This is a purely knowledge portal. Okay, I'm following this Intel standards around 4 years or past 4 years. Okay, Intel is providing how to do it, how to get it. Okay, this is you need to work. Okay, then only you can able to learn. So I shared that link also. Yeah, all the PPTs is available in this link itself. You can able to get the data from this link. Yeah, even if you want to learn, and I don't want to learn DL, I want to learn NLP. Okay, so without DL you can't learn NLP practically. But even if you want to do that also, you can able to do it. Okay, so I'll be sharing Intel is. Sorry, it's some. So if you want to learn ML or DL, AI, everything you can able to get support directly from the Intel R&D people. Okay, NLP, time series analysis, deep learning for robotics. If you are focusing, if you are a student, please focus on time series analysis and DL. Okay, I'm sure that you are having a huge opportunities in time series analysis. Okay, so you should know what is time series analysis. You should work on how to work on time series analysis. It's a critical thing. The opportunity is very high for the time series analysis. Anomaly detection. Even if you are an electronics guy, you can connect the deep learning in FPGA also. Okay. So how can you able to connect these things? Everything is for free of cost. You can able to get this data directly from the Intel. Okay. I think I clarified a little bit on what is CNN. Practically, if you are saying, yeah, you got clarified, practically it's not possible. You have to sit and work at least for 5 days for CNN, then only you can able to understand what is CNN it is. Till then you can assume, oh, this is nothing but CNN, or that is nothing but CNN. Practically you won't get those knowledge. So you have to sit and work, then only you can able to get what is CNN it is. Okay. So I think not only CNN, any form of an algorithm that you guys knows very well compared to me. Okay. So I would like to thank the madam and the faculties and also the management who connected me for this webinar. If you are having doubts, please, I can able to help you out.
Yeah, thank you, sir. Thank you so much. Participants, sure. Is there any questions? So there is one question.
Yeah.
Is there any data loss during subsampling?
Yeah. Again, it's based on the filtration. Practically, you will be getting a data loss. Okay. You need to modify the kernel again, so that you should not get lost.
Sir, another question: difference between AI and ANN.
AI is a artificial intelligence. ANN is nothing. It's a neuron. It's a part of AI. That's it. Okay. So a methodology. CNN you are having in a scalar methodologies. There you will be having a vector methodologies. Okay, but at the end, all these methodologies connecting to the AI. So these things are all a small components of AI.
Any other questions? For image processing, we can use either CNN or ANN.
Again, practically, I can say CNN, ANN, RNN. Okay, again, it's based on your requirements. For classifying, CNN is advisable. Again, if you are falls in some other category, you need to focus. I mean, if you are focusing on XK images, please focus on EN instead of connecting to CNN. Okay, it's based on the problem statement or the requirements. Okay, you need to change your methodologies.
Okay, sir.
Please don't stick with any methodology. That's best answer I can give.
Okay. Okay. I think we are running out of time. Thank you, sir. Thank you so much for your valuable
Okay.
suggestions and sharing the knowledge with us beside your busy schedule. You have shared
Okay,
something
okay,
for all the participants. I hope participants would have got some idea about what is CNN.
Okay.
I thank to our college management for giving me this opportunity to present this webinar. Thank you, sir. Thank you so much, participants. Your link has been posted in the chat, feedback link. So you can fill up this, and also we will send the mail. Same we'll be sending in your registered mail also. And I thank our HOD ma'am, Dr. Kalarani, for giving this opportunity to conduct this webinar as a successful event. And I also thank for my co-organizer, Anslam Sibi, for organizing this webinar. Thank you. Thank you so much.
Thank you, ma'am.
Thank you. Thank you, participants.
Thank you, ma'am.
Thank you, sir.
All the best.
Yeah, this feedback link will be active till tomorrow. All the materials, PPT, everything will be shared to your respective mail IDs. Sibi?
Yes, ma'am.
Yes, Sibi.
Yes, dear participants. Feedback link is sent to your mail ID also. You can fill the feedback form through your mail. And once you fill your feedback form, you'll be getting the certificate to your registered mail ID.
Thank you, Sibi.
Yes, ma'am.
I think we can close the session.
Yeah, ma'am, you can wind up it.
We will wait for 5 minutes.
Yes.
If the participants has any doubts, we can clear that.
Sure, ma'am.
I think no more queries from participant side.
Yes, ma'am. We can wind up. We can close the session, ma'am.
Yeah, Sibi. Thank you, Sibi. Thank you so much.
Yeah, thank you, ma'am.
Thanks,
Thank you,
everyone.
ma'am.
Thank you.
सर्वंत लकड्या म्हणे हा लकड्या समजा तुम्ही